This is a brief presentation about the poster that you can look at your leisure on the Padlet as well, on the same Padlet that this presentation is being presented on. But I wanted to give you the overview, the verbal overview, and look through some of the pieces of the poster. And I'll let you read the introduction, which is here, and the context, which is here, and I'll just really focus on explaining the images and the graphs so that you can get more of a context from this presentation. So this is a site here in Marina where I have actually several fog collectors, but the ones that are of interest in this poster are labeled A, which is this device here, which is one of the FM-120s, B, which is a standard fog collector, of which I have 3 at this site, but we're only looking at one of them here, and C, which is another FM-120 device. Now, what's interesting about this is the wind during fog events is going to blow in the direction from C to B to A. It's going to be blowing basically from the northwest, and this fog collector is facing northwest. And these 2 FM-120s are devices that collect the droplets of fog water and count them and tell us what sizes exist and how many of them exist in the range between 2 micrometers and 50 micrometer diameter tiny little fog droplet particles. So what happens is this FM-120 is the one that collects the measurement before it reaches the fog collector. So from the measurement that we get from this, we can determine how much liquid water is in every unit volume of air, every cubic meter of air. How much liquid water is there? That's what this device here will tell us. It tells us a lot more detail than that, but that's the biggest measurement that we're going to be using here within this study that you'll be doing, is the liquid water content that this device picks up. The fog collector is then going to pull that liquid out of the air, at least some percentage of it, and it's going to drip down into this rain gauge where it's measured and then drips down to the ground. Then this fog collector is positioned behind this one. This FM-120 is positioned behind this fog collector, and it measures the liquid water content of the air after it's passed through the fog collector. So with this set of 3 instruments, we can do what really hasn't been done much before, and we did it for months, and that's to measure what the efficiency is of this fog collector in extracting water out of the fog and into a composite liquid form, basically liquid water, that's measured by this rain gauge. And these 2 instruments provide the kind of the before and after. You could think about it that way. And so it's kind of an accounting. This is the money coming into my bank account. This is the amount of money I'm pulling out, and then this is what's left afterwards. You can think about it in that context. In a few abbreviations, SFC is the abbreviation for Standard Fog Collector, and that's the device that was in the middle, device labeled B. The FM-120 is the device that measures and counts the fog droplets. This should be micrometers and not millimeters, but millimeter is much bigger than a micrometer, but I'll have to fix that. The collection efficiency is the fraction of the water in the fog that's collected by the standard fog collector and measured by the rain gauge. And so there's different types of efficiencies we're looking at. One is how much of the water is actually intercepted by the fog collector. That's basically what this is. And the other one is called the drainage efficiency. Not all the water that's collected by the standard fog collector makes it to the rain gauge. Some of it blows off. The little droplets miss the rain gauge. They don't actually make it into the trough. And so the drainage efficiency tells us what percentage of the water is actually lost. And we have a means of measuring these based upon this equipment that's out here. And these are actually often theoretically calculated, but we have a way of actually confirming what the actual measurements are in different fog events. And then LWC refers to the liquid water content, which I mentioned. It's the volume of liquid water that exists within a certain volume of air. Here's what we got from the data, and this is the kind of thing that you'll be doing in this report. The red represents the liquid water content measured by the FM-120, that's labeled C. It's the one that's in front of the standard fog collector. And you can see that the water measured by the FM-120, it should be greater than this total volume here. If you add up all these liters, it should be greater than the amount of water that the fog collector collects. This ratio, you could think about it as it's the ratio of the amount of water the fog collector collects to the amount of water that's available. And we calculated that. That's the collection efficiency, which is, in this case, for this event here, was about 16%. And for this event, it happened to be about 27%, which is interesting. In this case, it was actually 87%. It was larger for reasons that this is larger than we would ever expect it to be. And there's reasons for that that are described in the poster. But that's what this graph shows you. And one of the things I'm hoping that you can do in your project is to find a couple events and see if you can determine the efficiency of the water collection of the fog collector during those events using the same methods that Ted applied to come up with this graph right here. Then the next image here shows the ratio, or two different numbers. The white data here is still the same water collected by the fog collector. It's the same. You can see the shape looks the same here. The axes are slightly similar, but the shape of the white one is identical to the shape of the white one in the last slide. It's the same data. The red one's a little bit different though. The red one represents the difference between the front fog collector and the rear fog collector. In other words, in a perfect world, the difference between these two should be the same as this. So we're actually, the reason we're not getting the same amount of water collected from the fog collector that's equal to the difference between the two FM-120s is because some of that water collected by the fog collector doesn't make it to the rain gauge. So this efficiency here tells us basically how good things are at collecting the water that's the meshes are gathering. And you can see it's below 100% as we would expect, but it's greater than in the previous case, which we would also expect. So in any case, this gives another efficiency. And again, this is something that you can calculate with the data that you'll have available to you. And then this describes why we're getting an efficiency so large, 128%. That doesn't make sense. The reason, because you can't have anything greater than 100% if it's truly an efficiency. And the reason is that we believe that the FM-120 is not measuring larger droplets of water that the fog collector is collecting. So we're actually getting more water here, theoretically, according to this measurement, than was even present in the air, which is impossible. It means you're extracting water from somewhere. And we're not. I think that there's larger droplets of water that happen to be in the air that the fog collector collected during this event. During these events, it makes more sense because the water the fog collector collected is less than that which was available for it to collect, which is the red. And then we have some conclusions which basically go through some of what I talked about and comparing these efficiencies to those that are reported theoretically in the literature and to the one or two other studies that ever did anything like this. There's only a couple that have done something like this, but not for as long as the data that we're going to be able to be using for our study. We have these instruments out for months, and so there's a lot of events, and your job will be to find some of those events and see if you can determine the efficiencies, and I'll go through how to do that later. But that's what is on this poster. And there are some references here that I can make available to you. These are some papers that address related work. One of them I am an author on, and the other ones are done by colleagues from around the world. Okay, so that gives you an introduction to the data results that I'd hope to see maybe one graph of from you for this project.